All right. Okay, able to hear me?
Yes, Prof.
All right, nice, thank you. All right, yeah, so let's get started. Right, so the first half of the semester, we spent most of our focus on implementing user interfaces with technologies such as HTML, CSS, JavaScript, and React.js being a JavaScript library dedicated to implementing single-page applications. And so the most of our focus has been focused here, right, in implementing on the browser a React.js application that implements a user interface, right, that interacts with the user. It receives input from the user, so users can fill out a form, right, and they can create content, type, and move the mouse, right, and so all this input and interaction, right, is what makes the user interface. So that's what we've been focusing for the first half of the semester, right? Now for the second half of the semester, we're going to be focusing on the next tier, right, in a multi-tiered application. So we are working in a multi-tiered application, right, where you have at least 3 tiers. We have the first tier being the user interface, the middle tier being the server, Node.js server, right, and the last tier being the database, right? So the database we'll take a look at in a couple of weeks. We'll add that to this multi-tiered application. But for the next couple of weeks, we're going to be focusing on this half, right? On the Node.js with the Express library implementing an HTTP server that rounds out the client server application architecture that we've been implementing for the last several months, right, in the course, right? So yeah, so we've been focusing on the browser side, really the user interface, which is also often referred to as the client, in a client server architecture. So we're going to now change our focus, right, or focus more on the second half of the architecture, right? The server. We'll implement the server. We'll talk about how we're going to integrate these 2 halves of the same application, right? So that they integrate by using a model called the request response model, right? Where the client sends a request to the server and the server then fulfills that request and then responds with the results of having fulfilled that request. Okay. There's a question on the chat. Let's see. Oh, it seems we need access to A5. So A5 is still, I'm still tweaking it a little bit because I had to change a few things in the prior assignments, making a few things optional and also extra. So I had to tweak a few things. I'm not quite done with the 5th assignment, so let me finish it up, and it'll be available on Thursday. So Thursday is the due date for the upcoming assignment 4. And so when that's done, I'll release assignment 5. So yeah, so that's the focus of the next couple of weeks. So let's look at the syllabus just to make sure where we are. And we have again for the first half of the semester, the first 7 weeks of the semester have been focused on implementing the client-side application running on a browser, which is a client application, to a server that we are now going to be focusing, right? So the second half of the semester, starting today, right, we'll first focus on introducing Node.js, how to interact with it, how to send requests, response, how to parse, how to send data, receive data from the server. right? And then after that, right, we're going to be adding the last tier to this multi-tiered application, which will be a Mongo database, right? Also, I will be, interspersing in my lectures, working on prototype of the project, right? So that you can follow along and have an idea of what it is that we are asking you to do, right? We'll look at the requirements, right? And then I'll have examples of what I mean by some of those requirements. The access to assignment 5 will be later this week, when assignment 4 is due. I believe that's on Thursday. I'll release this on Thursday. So yeah, so MongoDB in a couple of weeks. I'll intersperse a couple of projects and work on the prototype. You should be working on the project with your teams. You already have plenty of skills to get going with at least creating a prototype of the various screens and forms and data models that you're going to be using to represent your objects on the client, at least, right? And you can already implement some of the navigation, from one screen to the other, any data that you need to pass from one screen to the other, any parameters. You can already start styling it, so that it looks professional, polished, finished, right? So all that you should be advancing that and working on that. Make sure you don't leave this to the last couple of weeks. I'm sure you'll be plenty busy at the end of the semester with many other projects and assignments from other courses. So whatever you can do to start working on that as early as possible, right? I would definitely do that. I would say the hardest part might be the interaction with a third-party API. So that's what I'm going to be demonstrating. Not today, maybe perhaps later this week, on how is it, what do we mean by interacting with a third-party API, and how is that integrated with the rest of the project? Okay. Also, the midterm, I'm going to release the answers to the midterms later this week, perhaps tomorrow, and I'll make a post on Piazza, and the intention is for you to respond to that post, right? Review your exam, take a look at your answers, where you lost points, and if you don't agree with something in the midterm, that you maybe misspelled something, and you think that we could give you partial credit or whatnot, you want us to take a look at a particular question, please respond to that post, right? So I'll be releasing the answers later tomorrow. What else? Oh, so yeah, I'm probably going to move that quiz, so it's not this week, it's next week. I'm going to move that Q3 to next week. It's kind of too close to having just completed the first exam. So people must be exhausted. All right. What else? Any questions? All right. So the focus of the second half of the semester is building HTTP servers, right, for our client server application. And there's many different servers that we could have chosen, right? Definitely different. There's servers implementing for Java, .NET, Python, PHP. There's tons of various architectures and infrastructures that allow you to implement servers, right? But since we are already working with JavaScript in the front end, I think a good choice is to use as well a JavaScript-based server, right? So we're going to be using Node.js. A lot of the techniques that we are going to be covering today, are equally as capable or available in other infrastructures. So a lot of the topics that we're going to be covering, right, apply as well if you're using, Java's Spring MVC or using Tomcat or using Python, or any server-side technology is going to have an equivalent implementation of the topics that we're going to be covering, right? About how to encode data and pass it to a server, either it's path parameters or query parameters, right? How to encode things in the body and send it over in a JSON representation over to the server, right? How to parse that coming in on the server or from the server. So all those topics are equivalent across multiple infrastructures, multiple languages. Obviously, the language is different, the syntax is different, right? But the topics and the principles are all the same. Okay? So Node.js. To download Node.js, you should already have a Node.js downloaded and installed on your server. Certainly, at the beginning of the semester, we installed Node.js and used it to create our React application. We're using npx create React app, right? So definitely you should already have Node.js install your machine. Certainly we have been using Node.js all along, right? Our React applications are running hosted on a local Node.js server, right? When you type npm start at your React application, it starts up a Node server locally on your machine that hosts your React application on port 3000, right? So we're going to learn how is it that these servers work, right? How do we create those servers, right? Although the servers will take on a slightly different role, right? In the Node.js server that we're currently using is hosting the React application. So it's hosting the user interface. The Node server that we're going to be building is not going to be hosting any user interface, right? Instead, it's going to be hosting data, right? It's going to be providing a lot of the requirements that the user interface needs, right? A lot of things that the user interface can't do. So, for instance, right, in React.js, running inside of a browser, those applications are limited by what the browser allows the applications to do. So for instance, the browser will not allow your React application to access the file system, right? It doesn't allow it to just make network connections anywhere it wants, right? It can't connect to a database, right? It has some limitations imposed by the browser because of security concerns, right? Now, the server that we're going to be implementing is going to not run inside of a browser, so it's not going to be constrained by the browser, right? The browser, there's no one to stop it from doing whatever it wants, right? So it's going to be, executing from a console, right? And it'll have access to the resources that any program has, right? When you run it from the command line, right? It will have unfettered access to the file system. It can make network connections wherever it wants, right? It can connect to a database, right? So a lot of things that you can't do on the browser, we're going to be able to do on the server, right? And vice versa, right? On the browser, you have all this, graphical user interface. You can draw on the canvas. You can, consume content from the keyboard, from the mouse, right? From the camera and things like that. Things that you can't do on the server, right? Well, not trivially. So these two sides of the application, they complement each other, right? One thing, things that are not possible on one side of the application are possible in the other, right? And they're going to complement nicely. And now we do have to integrate these together, since these two are independent of each other, right? They run in a completely different environment, in a different process, right? And eventually they will be deployed to completely different servers, right? The React.js running on Netlify, whereas our Node.js server is running maybe on AWS or Heroku or Render.js, right? So So they're going to be completely different, separate, right? One might be running somewhere on the West Coast, and the server might be running on the East Coast, right? So we do need to learn how to integrate. How is it that they are apart, but still, part of the same application, right? So we're going to learn how to integrate these, right? And the way they're going to integrate is through the use of HTTP. So the HTTP protocol will be used, right, to send requests from the client running on a browser over to a server running on Node.js, right? And the server is going to process the request, right? It's going to fulfill that request, right? And then respond back to the client with a successful response, right? So yeah, so that's where we're going to be, right? Implementing HTTP servers using Node.js. Okay. All right, so let's see that if we have Node.js running available. And so let's bring in a terminal, and that terminal, if you do node -v, it shows that I have a kind of older version of Node, right? But if you have version 18 and older and newer, you're good, right? So what is Node? Node, again, Node is the only thing Node is it's a JavaScript interpreter, right? It's a runtime for the JavaScript language, which basically breaks out JavaScript free from the browser, right? Whenever you think of JavaScript, you're thinking, oh, it's a program that gets downloaded from a server and then it executes on the browser, right? And that's mostly true, right? It has been true at least for a decade and a half, right? But with the advent of Node, right, the language has broken free out of the browser, and now it can run on the desktop, right? So let's create a project, right, where we can build our server. Let's see, and so let's go into NU, and let's go into 2023 and fall, and into CS5610, right? And in here we have our Canvas React web app application, right? So what we're going to do is that we're going to create another project, right, in parallel to this one, to the React web app, right? And it's going to be an entirely separate code base, right? It's going to be stored in a completely different GitHub repository, and it's going to deploy to an entirely different server, right, of your choice. It could be AWS, it could be Heroku. I'm going to be using Render.js since it's trivial and it's free. So yeah, so let's create this new project. And so we'd start by creating a directory. So it'll be Canvas. So this will be so this is going to be a not React. This is going to be a Node, and it's a server application. All right, there we go. So so we created a directory. There's the Node server. So let's go in there now. And there's nothing there, right? There's nothing that's empty. So let's open it up with our favorite IDE. Let's see. And let me close this. Let me open up a folder that we just created. So this will be 5610, and this is Node. Okay, this is the one that we just created. And it's empty, there's nothing in there. So let's create our first file in there, and let's start with something trivial. Right? So let's start with hello.js. And in hello.js, again, the intent here is that we can execute JavaScript, right, outside of the browser, right, from the command line and on the desktop. Right? So this is a plain old JavaScript file, and you can do pretty much anything you want that you could do with JavaScript, except for, right, you don't have what you have on the browser. On the browser, you have HTML, you have CSS, you have the DOM, and And React.js is basically a library for dynamically manipulating the DOM, right? Here, you don't have any of that. There is no DOM. And there is no input, there's no typing, there's no user interface, right? But nevertheless, you have the language, right? So you can write anything that the language could do. You could write, obviously functions, classes, loops, branches, everything that the language can do, and do data structures like using JSON and whatnot, right? And what we're going to be using it is to implement servers. Okay? So there we have a console log. So if we go back to our terminal, there's our hello, and we can now run it. We can say node hello.js, and there it is, right? It runs hello world, and then it quits, right? It's done. Yeah, so we're going to be using Node.js to implement web applications. So how do we implement web applications? Well, Node HTTP servers. Right? The whole thing is a web application which has two pieces: the client running on a browser, right, and the server running on Node.js. So to create the server, we're going to be using a very, very popular library called Express, right? And all the libraries that we've been using so far, create React app and whatnot, all the libraries that we have been installing, they're all available here in npmjs.com, including the Express library. So we can look up Express. And Express is by far one of the more popular libraries, right? So it's, there's 29 million weekly downloads, okay? And here's the documentation. I invite you to explore their documentation, right? It's very well documented. We're going to be using the most common features, right, in Express. There's plenty more, but I think we'll be covering, I don't know, maybe 20% of the features. But with that, you can do 80% of everything, right? Of the most important stuff, anyway. So yeah, I encourage you to explore the documentation. But we're going to install it and create our application. So let's do that. So back in our terminal, right, we're going to install Express. Now, so the application that we're going to be using or implementing, it's not just going to be just one file, right? It's going to be dozens of files, right? And it's going to have a lot of dependencies, right? Including the Express library, plus a whole bunch of other libraries that we can install. So typically when you have such a complex application, it's not sufficient to just have your JavaScript file, right? You need to also manage all the libraries that your project depends on, right? So it is a standard practice that we don't just have the files, but instead we have a full-blown project that tracks the dependencies, such as our Express library dependency. So to do that, to create a project in a Node.js project, we use the npm init command, right? So that starts off a little wizard, right? That's going to ask us a few questions on, what do we want to call the application, who the author is, and whatnot, right? So by default, the name of the application is taken as the name of the folder, right? So I'm just going to just accept the default, right? And what it does is that it captures your configuration of the project in package.json. That's a giveaway that this folder represents a Node.js project, okay? So yeah, and if you look at it in here, it says who the author was. I could have said it's me, right? And it's guessing that the entry point is hello.js, which is not correct, right? We're going to actually create an entry point for our application, and that is going to be it's going to be app.js. App.js is going to be our entry point. This is the equivalent of our React application, the app.js in React, right? This is kind of the equivalent, right? This is the entry point of our Node.js HTTP server application, right? The app.js on the React side is the entry point of a single page React-based web application, right? So app.js is going to bring in the Express library. Let's install it first. So we install it by saying npm install Express. Right. So it's going to copy down from npmjs.com, right? And what it does is that it creates a node_modules directory, and it copies all the library files in there. Everything that's in there is binary content, right? That none of that should ever make it into the source control, right? No module underscore in source control. Okay. So we have that. We have Express. Now we can bring in the Express library from our app.js. Say const express equal require express. Now, so this require express is the equivalence of the newer, more modern syntax of import, right? Today, you would say import express from express, right? So this is using an older syntax called CommonJS, right? That is a precursor, right, to the more modern module syntax, right? So I'm only pointing it out. We are going to abandon this syntax very soon, but I do want to make you aware of the syntax, since there's a lot of documentation still out there that uses this older syntax. So we'll fix this in a minute. Once we have the Express loaded, right, we can create an instance of it, right? Const app equal express. And so this creates an instance and a reference to the library, right? And we assign it to this constant application app. And once we have that, we can start the server, say that we are listening at a particular port. So we know that we're using 3000 for the React application. So I'm not going to use the same port, otherwise it's going to be a collision if both of them are running on the same port, right? That it could be, it won't let you. So there it is. So in 3 lines of code, we have an HTTP server, right? So let's try it out. We can go here and run it. Let's say node app.js, run it. Notice that it didn't come back right away, right? Unlike when we ran hello.js, app.js is not printing out anything, it's not doing anything. It almost looks like it's stuck, right? But it's not, right? What it is that it's forever, the server is forever waiting for an incoming request at port 4000. Notice if I stop it, right, the server was running at port 4000. So, and it's the local IP address of my machine. And if I ask for something, it's that it can't find anything at that IP address and that port. But if I run my server, right, and then I do a refresh, notice that this is a response from the server. It's an error response saying that I asked for something and it doesn't know how to fulfill that request. Right? So it's complaining, saying, I don't know what you're asking for. So I believe what it came back with was a 404. We can see in the network tab, we can see the request. So let's refresh. So there it is. See, it came back from the server as a 404. You ask for something, I don't know where it is, and I'm just responding with a 404. So we can go back here and actually tell it, what we want. Okay. And the way we do that is by using the Express instance, right, and creating what are called routes. Routes is in general, a route is a mapping of some path, right, to some resource, right? And we've been using routes already, right, in our React application to implement navigation, right? That was the process of mapping, right, path names to components, so that if the path name matched, right, if the URL path matched the route path attribute, right, if it matched, then we would display a particular element, right? kind of like an if else, right? If it matches this, we do this. If it matches that, we do that, right? So here we're gonna have the same similar thing, right? We're going to implement routes. We'll say if your incoming request, right, comes in as a get at the root slash, and then we can respond. We can send back a hello world, or maybe better, welcome to web dev. Okay, so that if I notice if I go to my browser and I refresh, I still can't find it. Right? That's because it's the server was never restarted it, right? So it's still working with old routes or lack of routes. There are no routes, right? So it doesn't know how to fulfill it. But if we restart the server, refresh the browser, notice that indeed now it comes back with web dev. And there it is. So there's a request going out, 127.0.0.1. There it is. It's a GET request, right? And that's why this code is app.get. .get means that there's a GET request that's coming into the server, and I am trying to pattern match the path against the first argument. If it matches, right, then I execute this function here, this anonymous embedded function, right? And the express library passes two objects, right, that are in that order. Okay. The names of the constants don't have to be those names, but those are very common names to use for these constants, right? And which represents the request and the response, right? The request coming in from the client, right? And then the response that I'm going to generate to send back, right? And here I'm using the request to send back a communication saying to welcome to web dev, right? And the way I access it is by running it over here with a slash, right? So it maps that, it matches the slash, which says welcome to web dev. Now notice I'm trying to, another example I would like to explore is to say, just say hello. Now again, there's nothing mapped to that path, right? So I can go back to my code and actually implement it. I can say, hey, if you receive a GET request, right, to that URL, then respond with something appropriate, right? So we can do that by saying app.get and hello. Right? And we can send back a hello world like that. Right? So that if we try to do this refresh, we need to restart the server. And now if I refresh, I get the hello world. Okay. And now it's very cumbersome to having to restart the server every time we make a change on the code base, right? So instead, we're going to be using a tool called NodeMon, right? So NodeMon is a tool that listens for changes in the file system, and if it detects the file system, right, it restarts a program. And the way it works is that you do instead of Node app.js, you do NodeMon app.js. Okay. And now it's listening for changes in that file and any dependencies. And if they change, it restarts the server, right? So that it's always working with the utmost latest stuff, right? So now if I make any change, if I go back and I make changes and I say, life is good, and I save that, notice that it restarted. See that? It restarted due to changes. And without restarting it, without me physically restarting it, and I refresh, notice that the changes have taken effect, right? Now, this is already happening in our React application, right? So this is nothing new. But that one was configured like that out of the box, right? It was a boilerplate standard configuration, right? That was already configured to listen for changes, right? And recompile the code, right? And be up and running in a few seconds, right? So yeah, there it is, right? There's our very first route. Now we're going to be working with lots of routes, for the remainder of the semester. These are just 2 dummy ones, and so it's common that we break out the declaration and implementation of our routes, right, into dedicated route files, right? So what I'm going to do is I'm going to move these hello related routes. I'm going to put it in hello. There we go. Now, one of the problems of putting it here is that we don't have the app. We don't have a reference to the app here, right? So notice you should not recreate the app, right, in every single place. Instead, you have to instantiate only once and then pass it around as arguments, right? As these are included or imported. Sorry, Professor, could you explain the app get request response again? Yeah, so these are routes that are listening for incoming requests, and if the pattern matches, right, if /hello matches with /hello, then it executes that particular route, right? It does some work, and then it sends back the response, right? So the request is going to represent everything that comes from the client, from the browser. The URL itself, any query parameters, any path parameters, any timestamp, right? The IP address of the machine that it's coming from. So all that is available, and we passed it to the server, and the server then passes it to us in the Express library, and it knows that you can, if you want, right, use the response to send back some data based on the data that you passed in through the request. Okay. So anyway, so we're going to be looking at this much more in depth in a few minutes. So anyway, we don't have a reference to app, so let's fix that. We're going to wrap this inside a function, and we're going to call that function hello reducers app, right? And then we're going to export it. Well, hello reducer. Wait, no, hello what? Not hello reducers. Hello routes. That's what I meant. Sorry. Okay. And so we need to import this, right? Now, I don't want to import it using this old syntax. So instead, we can bring in the new syntax, right, that uses ES6, right? So to do that, go to the package JSON and change the type of the project. And we have, and then here we're going to do module is the more modern. Is a more modern option. So the type, we're going to go with, there it is. So there's 2 options. The default one, which is already the one that's running, it's CommonJS, right? So there's an older syntax. It uses the require, and it has evolved and matured over the years into include. So we're not going to use CommonJS. Instead, we're going to use module. So module is going to allow us to now, instead of saying require, right, we can say import express from express, right? And then we can use it just the same, right? So anyway, here's hello. Notice that it can't really be implemented unless we have a reference to app. So what we're going to do is that we're going to import. We're going to import the hello routes, and then we're going to pass in. I'm sorry. We're going to bring in hello routes, and we're going to pass in app. So app is we're going to allow Express, right, to implement all the routes and the various handling parameters, parsing parameters, and things like that. That's all in there. right? So if I say hello, oh, it's not running. The server's not running. We need to start the server. npm, oh, it is running. Oh, crashed. Oh, yes, I forgot something. So here in the I forgot the extension, right? So in React, it is configured to be a little bit lazy, right? So that if it doesn't see the extension, it assumes that it's the JavaScript extension, and so it uses that. Here, we have to be explicit about it, right? So there it is. So I replaced it, and then we can then refresh here. Hello. I guess we want to see the hello routes, right? We did that already with the hello, so that's working, right? Okay, so that's what it's coming back as. Okay, welcome. So the hello routes. Yeah. So now let's focus on the actual exercises and practicing, right? Creating the multiple labs and whatnot. Okay. So let's take a short break, right? And we'll come back right after this. What happens if we need to change? Sorry, what happened that we need to change the JS? Needed to change the JS. No, I mean the file has a .js at the end, but the import didn't have the full name of the file, right? So in React.js, you get for free that it assumes that you either have an index file, right, or there's an actual file with .js. Here, we're not doing that. It's a pain, but so you can do it in your environment variable, right? Yeah. So let's take a short break, and we'll come back right after this, right? Okay, yeah, so we've been taking a look at how to create some really simple routes, right? And broke out our first routes into a hello routes file, right? We imported it and we passed in a reference to the Express library. So let's do a couple more things, a little more interesting things. Let's see. Wait a minute, let me, can you see my screen? Yeah, okay. And where is my, okay, code? Let's bring this over here. So we installed the Express library. We did a few routes. We're doing NodeMon, right? And so yeah, so let's start looking at first how we can exchange data, right, between a client application and the server application. First, we'll do some really simple examples on how to do that, right? And then we'll gradually get more and more sophisticated, right? Okay. So let's see. So there are a few different ways that we can pass data between a client and a server, right? One is by encoding it in the path, right? So like embedded inside of the path elements, right? We can include in the path data elements like integers and strings and whatnot, right? Or we can include it at the end of the URL, encoded in a query string, right? So let's take a look at first the path parameters, right? How does that work? Okay. So first, let's create a component let's create a file where we can work on various examples, right, exercises, right? So these are same exercises that are going to be available in the assignment 5, right? And so I'm going to share all these exercises with you on GitHub. And again, make you can do whatever with them, whatever you want, right? If you want to reuse them as your own, right, for completing the assignment or useful for your project, feel free to reuse anything I share with you. Okay? So let's create a file here, and we'll call it lab5.js, right? And in here we'll create a function. We'll say function, say lab5, right? That takes as argument the app, a reference to the app express instance. We're going to export this lab5, and so let's create a couple of routes, right, that can take arguments, right? So for instance, you would do something like get, right? And maybe we could have here an A5, and so that and then respond with just a welcome to lab 5, right? Like that, right? And we can import this in app like this. Say import lab 5, and then we can pass it a reference to app like that, and then we have a NodeMon that is restarting the server for us, right? So that we don't have to. And let's bring let's bring over. Oops, wait a minute. Let's bring over here so that we can try out, and communicate with our server. So to communicate, we can say localhost 4000 because it's listing at port 4000. And if I say /A5, oops, right, it comes back with welcome lab to lab 5, which is what we have here, right? Welcome to lab A5. So it's pattern matching this URL path, right? It's pattern matching it with this, and it's executing this function. Now, this function, some folks find this syntax a little bit disturbing. So I mean, this is a function, right? So instead of having it embedded in there like an anonymous function, you could create an actual function. So you could say maybe const hello is equal to that function, like an arrow function, like we've been using so far in our React application, right? And then you can pass this as a reference, hello, like that, and this just works the same way, right? Works exactly the same way. So we can also create a path, right, that can be pattern matched against us passing a parameter, right? So you can say A5, and if I say hello, right, and then I pass a parameter name, right? We can send back a string, right, that embeds the name. We can extract the name. We can extract the name using the param. So what the server does is that so anything that is in the URL, right, that matches this, right? Notice this one has a colon in front of it, right? Meaning that we're trying to pattern match with something that starts with A5/hello and ends with something, right? Whatever, and that whatever, right? Right after at the end of that URL, we're going to give the name here of name. Right? And so what Express does is that it parses that URL that pattern matches here, and then parses it, creates a little object, and makes it available to us in request.params. So request params contains the object that we called here name, right? So here we're extracting it, right? And then we're using it to embed it and create a response with this whole string. Let's see, there's a question in the chat. Do we need use params here? So use params, that's a React.js web application hook, right? So that only works on React.js. Here, this is a server, right? And so there is no user interface, there is no React.js, right? There are no hooks. Okay, so this is just listening for incoming HTTP requests, right? And we're handling it on the server. That makes sense, Chia Sheng? So now that we have that, we can say A5 and perhaps you can say hello. Now notice hello doesn't have a match, right? It does not pattern match and matches this. Instead, this would pattern matches with A5 hello and something else, right? So if we say you're Alice, then it comes back with hello Alice, right? Like that. And so we can make something more interesting. We say app.get, right? That receives, A5 with the add, and we can pass in an A and B that we can then parse as integers. We can parse int these, parse int, okay? And then add them up and respond with the values of A plus B. So for instance, if we say, A add, and then 5 and 3 comes back with 8, right? And we can create also a version of this with subtract. So we can say subtract. And now these request.params, we could use a different syntax, right? We can instead use a destructor, like we'd say destruct A and B, right, from the request.params, right? So again, this is very, very similar to what we would do with a use params, right? And then once we have A and B, we can parse these. We can say, parse this as integers, right? And this would be parsed as integer as well, right? And then we can call here, subtract, right? It comes back with 5 minus 3 is 2. Make sense? Everybody good? Yeah. So. So notice that the way we've been interacting with the server has been through this URL that we're typing at the command line. A more sensible way that we want to do is that we wanted to integrate it with our web application, our React web application. So let's explore how would we integrate this Node server running at port 4000 integrated with our React web application that is running on port 3000, right? Eventually, these will be, one in, render.js, our Node server, and Netlify, our React web application. So it may be halfway across the world. Right now, let's just get it running at least in my same laptop, okay? So we'll need a another code window. So let's open up a new window. And let's bring in our web application. So let's see, there's our 56 and web app, right? Canvas, React, web app, blah, blah, blah. So this must be it. And let's see where we got. Git, checkout, A4. Huh? Oh, do I have a few things in here? I might already have a few things in here. Integrating the. Oh, okay, so I had already started working with the lab 5. So let's see. Let me get branch. I think we're in A5. Get status. So I'm just going to add that to A5, and I'm going to rename the branch. We'll call it A5 temp. Git add, git commit A5 temp. Okay, let's get back to A4 and git branch. Let's create a brand new A5 branch, right? So git checkout A5. Okay. All right, so let's start with npm start, and let's see what we have here. Okay, and so it's this one over here, but instead let's go here, and we can navigate to localhost 3000. There it is. Maybe it's a little bit too big. And we have some labs in here, but I believe, let's see, labs. There we go. And we have an assignment 5, which is empty. So in here, we're going to try and create some user interface that interacts, right, with our server application. So let's do that. So to do that, let's come here, and in our lab 5, okay, which we had already started, right now there's nothing in there. So let's create a component, right, that plays around with the exercises, right, that are implemented in our server. And let's see, the assignment, here's our assignment, suggests that we name our component something in particular. Let's see. Yeah, encoding parameters in a URL. So let's do that. Let's create a component here, JS, right, where we're going to play around with interacting with our component, with our server, right? And let's make that available here. And so let's copy that. And so what this is doing, right, it's calling our URLs as a hyperlinks. So this is just basically creating some hyperlinks that allow us to invoke our A5 add and A5 subtract and encode values in the path from input fields that we can edit, right? With these couple of state variables, right? So that we can edit the value of A, edit the value of B. You're using these two input fields, right? And as you type them, right, it's encoding the A and B values in the URL so that you can, when you click them, right, they go out to the server and the server adds or subtracts them, right? So yeah, so let's import that in our assignment 5. So this is encoding parameters in the URL, and let's go back to our A5. There it is. So this is our A5. Now we have the encoding, and we can type in 3.4. Now we can do it manually and encode it manually over here, or we can now click this. Right? Notice that it goes out to the server responds, right, with the results. And same thing here. Now this is not really integration, right? It's just the single page application, just navigating away from the single page application and hitting the server. Something that we could have done manually, right? Type in and it goes there. Real integration would be that if I click on the button, it doesn't navigate away. It just, behind the scenes makes the call to the server, captures the response from the server, and then it displays it here in the user interface, right? We don't know how to do that just yet, right? So just hang on, right? Later on in the exercises, we're going to learn how to fully integrate as opposed to just navigating away, right, and hitting the server. Okay? So yeah, so we have subtract works, right, and addition works, right, and I can change values. I can change values or something, right, and then it adds those two values. So there's some level of integration. Okay, so let's do something a little more sophisticated. Let's also learn how we can encode things in as query parameters. So instead of encoding data as part of the URL, right, instead we can encode it. Instead of using this, we can do the something different. We can encode it as at the end of the URL, we can put a question mark, right, and then give names to these values like this, okay, and B like that, and then we separate each one of the parameters with an ampersand. See that? And then the express captures this URL, pattern matches it with the path that you declare here, and then it parses out the values A and B's and their values, right? So let's do that. So let's create a little calculator. Let's create a little calculator. We'll say, .app get, and this will be, A5. We'll say, calculator. And now you would expect that the pattern that we want is that we want to pattern match something with ends with a question mark, and that the A is equal to A, like that, right? And unfortunately, it doesn't work that way. It only pattern, so the query string at the end of the path is ignored, right, for pattern matching mechanisms. The server does parse it, right, and it does provide the values for you, just like in the params, right? But it is not used for pattern matching. So which is only the first half, right? The actual path is used to pattern match, and then in the request you'll find the parameters parsed, right? So we're expecting something like HTTP : //localhost, A5 calculator with something like that, and at the end also an operation, and then we can give it what operation we want, right? So we can do that. So we can extract each one of them, but instead of the params, we're extracting it from the query. The query, instead of you request that, so request params parses it, but from the path, like that. See that? Whereas the request query parses it from everything after the question mark. See that? So once we have that, we can have a little logic here that if it's add that, then it's going to respond with the values A, B, and whatnot, right? Like that. So instead of sending A and B, I'm just going to send back. Let's declare here a result, right? And let's calculate the result for each one. So the result is parsing A and B. Otherwise, if the operation is subtract, right, we calculate the result. It says, does the order of the fields in the query matter? In here it does. In the path, right, it has to be in that order. Whereas in the query string, the order doesn't matter. Yep, good point. So we have the subtraction, and let's only just do those two, right? And so we're going to respond with the results, only the results, just the results. But the result needs to be converted into a string. Good point, yes. The reason that is that if this was an integer and we send back an integer to the browser could interpret that as a status code, right? So there's a whole bunch of status code, which the most famous one is 404. So 404 is an integer that gets sent back by the server when the server cannot fulfill your request, right? If something went wrong and they couldn't find it. So we don't want the browser to interpret this as an integer, as a status code. So we convert it into a string, right? If it's an integer, we convert it into a string. Makes sense? We can also maybe have an else else that, if it doesn't match any of them, we're going to say that the result is an invalid operation. Right? So let's try it out. Right? We can go back here and try it out. We can say, calculator, and we can encode A equal 43, and B is and B is equal to 32, and that the operation is equal add. Comes back with 75, right? Or we can say subtract. You can say subtract, and it's 11. Or if it's something bogus, right, it comes back with an invalid operation. Make sense? Then we could create a user interface around this, right? Where if we go back to our React application, we already had an input field that parses the A, that creates the A, creates the B. So we could create a version of this that is the query parameters that encodes the data. It's slightly different, right? So we can copy these two, but instead of encoding it at the end of the path like this as a part of the path, this could be encoded using calculator, again, using the URL that we're expecting, right? Saying that A is equal to A, right? And that B is equal to B, and that the operation is add, okay? And then the subtraction would be similar, but this would be subtract. Okay, so if we go back here and we go to our React, there's our query parameters. And if we click on it, right, it comes back with the values of the addition and subtraction. It works the same way, and notice how it's encoded in the URL. Everybody good? Okay. All right, so let's do something a little more interesting. Okay, so let's work with objects, right? So say we have an object on the server, right? So maybe an object declared up here, or perhaps an assignment, right? And we want to retrieve this data, right? This is very much like what we're going to start doing it, right? Currently, we are hosting a lot of data in a database on the browser, on the client side, and really that's not where it should live, right? It should really live in a database, right? So, but we don't have a database just yet. So a nice intermediate is to put it on the server, right? As an object, arrays, data structure that the server can load, cache that data in the server, and then you can start manipulating it, right? And that has the benefit that as long as the server is running, any changes that you might have made to a data structure will persist, right? Unlike the browsers, right, today, when you make changes, add content, remove content, update content, right? None of those changes persists, right? If you refresh the browser, it all goes away, right? It resets to the initial state variables, right? So we're going to start moving stuff to the server because we want some permanence, right? Some persistence. Eventually, right, when we have the database, that will be the ultimate solution, right? And we'll end up putting it there. But for now, we're learning how to create APIs. We need data, right? So if we want to get a hold of the assignment, we could create an endpoint that says retrieve the assignment, and it responds with JSON assignments. You see that? Up to this point, we've been using the .send method to send back, strings and things like that. But if you know that your data type is JSON, right, the proper thing to do is to use JSON instead of send. I mean, it would also work if you use send. Send is pretty smart. It can look at the data type of the arguments, right, and decide what it is that the encoding that it wants to use to send back, right? Notice that if you all encoding, if we go back, so this is being interpreted by the browser as HTML because the requests, right, if we refresh, if you go to the network tab, right, these are all the HTTP requests that the browser is making. And it says that the encoding, notice the content type, the server is coming back saying, hey browser, you should interpret this as plain text, right? It's just an XML document, a whole bunch of characters, just text, right? But it's not just any text, right? It's formatted the particular standard, which is the HTML standard format. Okay, so that's how the browser should interpret this. If instead now I'm accessing an object, right? If I go and access an object here, say A5 assignment, right? And notice that if I inspect this, right, and I look at the network tab, right, and I refresh, and notice that this is being encoded to the content type. The server is coming back that this should be interpreted as JSON, right? It is this URL is part of an application, meaning this is a data exchange between two parts of an application, right? Somebody's building an application and they need some data encoded as JSON, and there it is. Now the response really is just plain text, right? The response, if you look at the raw, it's just plain text, right? But it's not just any text, right? It follows a particular format, right, of curly brackets and colons and commas and whatnot, right? So I have a little plugin here that identifies this as JSON as the application, JSON content type, right, and then formats it nicely with tabs and new lines and whatnot, okay, and collapsible and blah blah blah. So yeah, so we can now. So yes, send is very smart. It'll calculate. It will know what content type to use, right? So you can send back anything with send. You can send back strings. You can send back HTML, XML files, PDF, Word documents, blah blah blah, whatever. But if you know that the content type is JSON, then you should use JSON instead, right? Which validates this to be JSON, right? And if it is JSON, then it adds the correct content type. All right. Let me close this. Okay. Now we can also just extract just a particular field. You can say I want just the title, and so this can send just a subset of the object as opposed to the entire object, right? And so that if you provide it, say, well, give me the title, so it provides only that string content, right, of the title. And we can also have it so that we can combine it maybe with a parameter at the end, and we can interpret that as meaning that I want to modify the title, right? So for instance, this here, we can maybe add at the end a property new title that extracts the new title using the new and improved syntax, that modifies the title of the object, right, and then returns maybe the whole object. Oops. Right, it updates the title with a new title, and then it returns the entire object modified, presumably, right? So if I go back, right, here's the object. I refresh, there it is, Node assignments, and if I ask for the title, it gives me Node.js assignment. But I could modify it by providing an additional parameter saying that this is actually an HTML assignment. Right? And notice that it returns the object as modified with the new title, right? So that if I ask for the object, it returns the new object. Notice that if I refresh, it's remembering that the object has been modified, right? So we don't need the question mark. Well, no, I mean, you can do it either way. You can use path parameters, or you can use query parameters, right? There's two ways to encode data, as part of the path, or at the end of the question mark with name value pairs. Now, we haven't talked about when would you use one and when would you use the other. Okay, we're just talking about multiple ways of passing data to the server. There's really three ways: path parameters, query parameters, or embedded as a JSON object inside of the body of the HTTP request. We haven't talked about that just yet. On this one, we have discussed two ways of passing data to the server, either encoded in the path or at the end of the question mark, right? Now, why would you do one or the other? We'll discuss it a little bit later. There are times when you would absolutely only use path parameters, or when you would only use question marks, right? Or a combination of the two, okay? So we're just learning about skills, or either passing as a path parameter or as a query parameter, okay? Yeah, so if it says params, that's a path parameter, okay? All right, yeah, so here's one of the benefits of using a server. Now the data is persisted, even though we are refreshing, it's remembering. So let's create a user interface that would allow us to interact, right, with this object. Okay, so let's go back to our web application, right, and let's create a little assignment object here as well, set assignment. And this is an object that has, I'm just going to copy the same assignment as here. There it is, right? And then we can create a little, UI around this, right? We say for assignment, and we can go fetch the assignment. We can say go get the assignment. Oops. And then we say, get assignment, like that. And this could be as a button, render as a button. And so this would render like that. There it is, right? But if you click on it, it navigates and retrieves the assignment. Notice that, again, the name is still persisted, right? So it remembers that, which is great. And then maybe we can create a little input field that will allow us to update the title, right? So we can say, we can also get only the title, say assignment title. And this would say, get assignment title. There it is. So that maybe put them in separate lines. I meant as a ruler, horizontal ruler. There we go. So if we click on the title, it goes and fetches the title. And we can also make a little input field that will allow us to modify the title. Right. So maybe we can have an input field here that assignment changes the title. Very good. It has an initial value for control, not as a text, right? And this would be, value is the assignment title. So this allows us to edit the title, presumably, right? There it is. So we can change it, but it's not actually changing it, right? This is still HTML assignment. We can create instead a URL, right? That looks like this, right? But it encodes at the end the new title, right? Which is the assignment title. There we go, right? And so this is so this is update, right? The assignment title, right? And so that and now I can change it. Wait, is it still recording? Yeah. Okay. So that if I change this to be the CSS assignment, right? And then I click on update, it goes out, changes it, right? And then it displays the CSS assignment. Right? I can retrieve it here. If I refresh, notice that indeed it has been modified, right? And if I refresh, so that's again, one of the benefits of using servers. Servers will have, as long as you don't reboot the server, right? The the data in the memory of the server persists much longer than in a browser. The browser, if you refresh, it's gone, right? But the ultimate solution is to put it in a database. Again, this is not truly integration between our React application. Ideally, we would update this. We would not navigate away from our single page application. It would modify it on the server, receive the response, and then update. Notice that now my local state variable still thinks it's Node.js application, Node.js assignment, right? So there's no way that I know of just yet, not yet, that this is now in sync with the server. The server says it's a CSS assignment. Here, the state variable says it's a Node.js assignment. Which one is it, right? So now we've introduced, a one level of complexity, right, where we are maintaining state in two different places. On the server, we're maintaining the state, which is the true state. Right? The assignment title has changed, and it is CSS assignment. But here I have a kind of like a cached, stale version of the assignment, right? And so we need to reconcile these two at some point, right? As a general rule, right, the server state will always win. Right? That will be the central source of truth. Okay, and so we have to deal with how to resolve inconsistencies, and especially if it's just one person using this application, there's not much danger of minor inconsistencies, right? And it's very easily to resolve these inconsistencies. The problem is when these applications are meant to be used by far more than just one person, right? You can have dozens, hundreds, thousands, millions of people, right, using the same server, right, all running the same React application on their browser. So millions of people using the React application running on their personal browsers, hitting a single server, because they're trying to say book a movie ticket or something, right? And they're seeing the seats that are available, the seats that are not available, and they're trying to pick a particular seat. You and thousands of other people, right? And so the as they came in and used our user interface, the React application went out to the server and made a query saying, "Hey, what seats are available?" And then responded to hundreds of people saying that seat A7 is available. But now is that true? Because people are starting to select the seats, and so those are not interacting, are now working with a stale version of the information. And how do you reconcile dozens of people selecting the same seat, right? And so that's definitely what we need to deal with, how to reconcile those inconsistencies. And you could take a very pessimistic approach, right, where the way to resolve that is that if you could determine the first person who made the query to the database of what seats are available, that person runs in a transaction, right, where any modifications are locked. Right? You lock the row in the database, perhaps for a few seconds, because this first person is looking at it, and it's the only person who can modify that data, the only one who can write to the database to update the database, whereas all the other ones have just read privileges, right? They can only see that the seat is available, but they can't change it. Only one person can. Once that person either times out or actually makes the change, right, then all the other ones are allowed to, again, how do you say, try again to grab control over that resource, right? And that's not very scalable. If you have hundreds, thousands, waiting on each other, something that is meant to be asynchronous and multi-threaded and everything running in parallel. Right now, you have it that it has to be synchronous, and it has to be folks waiting on each other, and there's a long queue, right? So no longer it's multi-threaded and parallel. Now it's all very sequential. So there's the other extreme of how to solve this, which is you use an optimistic solution, right? Where hey, everybody goes. I'm showing you this information. But it could not be true. By the time you actually click and say that you want seat A7, maybe somebody else might have taken it, and it's gone, right? So first one wins, right? And when you choose something that is no longer true, I'll just very politely say, oh, sorry, you lost it. Right? Somebody else was faster than you, right? So that's a more optimistic locking mechanism, and that's more typical the solution. Okay. So anyway, yeah. So we'll have to deal how the state on the client, right, synchronizes with the state on the server. But in general, we'll define the state maintained on the server as being the single source of truth, right, and that all the clients need to make an effort, right, to keep up and maintain synchronicity with the server, okay? And we don't know how to do that just yet, not yet. We don't know how to do that. Okay, so yeah, so we created a little calculator. Okay, so we retrieved the object, we retrieved the title, we updated the title. Very good, updated the title. And there's a couple of extra credits. Okay, so what about working with arrays, right? We want to be able to retrieve data in arrays. So let's copy an array of to-dos, right? And let's paste it in here. And so we have these to-dos. And we can retrieve those to-dos, right, by saying app.todos, very good. And then just respond that as an array, right? So we can go here and we can say, well, give me the to-dos. And it comes back as an array of to-dos. And we can make a user interface that retrieves that as well. Now, something common with collections of data is that we want, there's different operations that we want to do in a collection of data, like an array like this, right? And they're generally referred to as the CRUD operations. We want to be able to create new data in the collection. We want to retrieve either all the data or maybe a subset of the data, right? Or maybe some piece of data that meets a particular criteria, right? We want to be able to update and delete, right? Create, read, update, and delete, CRUD. So this is one of the many read operations, right? We are retrieving the entire collection, right? Another very common read operation is that you can provide maybe a primary key. And it says, okay, I'm going to give you the ID, and so that means that I don't want all the to-dos. I just want a subset of to-dos, right? And so I'm going to parse the ID from the parameters, right? And I'm going to look for the to-dos using that ID, right? With that ID, I'm just going to do a find. I'm going to parse the int, right? So once I find the integer, I find it, and then I'm just going to respond with the to-do that I found. Okay, so let's see. So we can say ID. So if I say 2, it doesn't work. Oh wait, not delete. There it is. It came back with 2. So there's the version of I have get all the to-dos, and there's the version where I give you the ID and it returns that one ID. And this is where the question earlier on whether we should use question marks or we should use paths. This is definitely a case where we would encode the parameter, this 3 here, we would encode it as a path parameter, not as a query parameter. To encode it as a query parameter, we would have to do something like this. We would say question mark, ID equal 3. We would do something like that, right? Equal 3. And so right now, this would match what? It would match this. And it would ignore the queries, right? So this would return all the to-dos like that, right? So we would have to implement here somehow to parse the parameters, the query parameters and whatnot, right? But again, for the use case that we are filtering using a primary key, right? That is absolutely a case where we would use path parameter and not query parameters. Make sense? So if I say 3, right, it returns that 3. Yes? Now, so let's look at a case where we would use a query parameter. If you are instead filtering, so if you're filtering by ID, then you definitely use the path parameter. But if you are filtering by any other field, okay, then you would use a query parameter, not a path parameter, right? So for instance, so this is completed. So let's say let's say that this is true, and this is true here. So we have a couple of tasks that are completed and a couple of tasks that are not completed, right? Because how is array being passed in? We're not passing in the array. The array is in the server, right? The server has the to-dos, and we are requesting it from the server. So the browser is requesting the array, and it is responding with the array, right? Yeah, so we're not sending it in. We're going to learn how to do that in a minute. Well, maybe later this week. So we're retrieving the to-dos. So here, if we're filtering by primary key, absolutely we would use the path parameter. But if we are retrieving by other than the primary key, then we do not use the path parameters. We use a query string. Okay, so say I want to filter by completed. So that means that I would not use the path parameter. I would use something like to-dos, and I would say, completed, equal true, right? And so this would filter out those to-dos, right, that are completed true, right? And if I say false, right, it would return only the ones that are false. Yes. Right now is that this is being handled by this one, right? That is returning all the to-dos. It's not doing any filtering, right? So let's parse that completed query. You can say, const completed from the query, and then now we can. Okay, so first of all, it comes in as a string, not as a Boolean, right? Not as a Boolean. And so we have to convert it into a Boolean, right? Let's see what our AI is going to do. If it's true, okay, it's going to filter. Okay, there we go. So what it's doing is that it's checking to see if it's completed as true, completed to-dos. It's filtering, and the ones that come back as to-do.completed, which are the ones that are true. And then we're just going to respond with the completed to-dos. Otherwise, if the completed is false, it's going to do complete. It's going to negate and do not completed. Yeah, that's a good approach, right? And then respond with the completed to-dos, right? Else, so what if I didn't find either one? Well, so by default, it's just going to return all of them, right? Going to do the complete return all of them, right? Maybe it's a good idea to put it inside of an else. Right? We could say, else return all of them, like that. And otherwise, we might. Okay, sorry, I missed the part. When do we encode in the path and when not? Right. So if we are filtering and finding things and the to-dos that meet a criteria, if we are filtering by the primary key, we encode it in the path, right? That's just a convention, right? It doesn't have to be that way, but it is by far, what we do in the industry, right? That if we are using primary keys, the primary keys are encoded in the path, but any other field, right, any other criteria other than the primary key is encoded in the query. Again, it's only a convention, but it's a very, very strong convention that is pretty standard, right? So yeah, so here we have true, false, blah, 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 filtering, and otherwise return all of them, right? Otherwise, if we don't find any of them, we can send back an error. We can say responds at send status 404. We did not find any of them. Actually, right now, this else would take care of that, right? We just return all of them. So yeah, no, this probably might be useful in here, right? If we don't get a to-do, if we do not find the to-do for that ID, we could return a status of 404. We can say, if no to-do, right, we can send a status of 404, right? And send a piece of text of to-do not found, right? Now here, if we send this, the execution doesn't actually stop here. It's going to continue to this second line over here, right? So here we would have to do a return. Return, say, no, don't continue. Otherwise, you're going to send an error, but then you're going to send null, right? So do we do a return there? Here we could do a return. Here we can do a return, right? But we don't need to because this one already returns over here, right? Okay, so let's try it out. So if we say completed false, right? Notice that it only returns task 1 and 3 because the task is false. Or true returns task 2 and 4. Make sense? Now you could have multiple things, right? Where you can have multiple criteria, that it's completed as true and that the due date was whatever in January, and and the budget was within a particular range, okay? And so you can have a lot of ampersands here, where you can have elaborate criteria, right, with a predicate, like a predicate that you would then be responsible for implementing in the back end, right, where you collect all those query parameters, and then you implement the actual filter based on your predicate, right? And it's whatever the actual implementation is, you would implement that, right? Okay. Right now we're only using one simple predicate of just completed. Make sense? Right. Obviously, these would we would need a user interface to interact with these, right? Right. So for instance, we could implement here working with arrays. So let's create a working with arrays, and this would be a function working with arrays. Okay, and then we export this. And so, for instance, we want to maybe retrieve an array. Let's see. Is there a cleaner way of parsing a Boolean from a string? Not really. I mean, you could say const completed, is equal to completed equal true. You could do that. And so now this is a Boolean, but this is basically a string. It's a string that needs to be compared against a string, right? And so that and then you can use comp here. So actually, this is easier, right? Where instead of comparing like this individually, right? You can say to-dos dot filter and then complete it, right? I guess we could rewrite this as const the actual arrays, right? We can make them into a let, right? And so this would be what? Let's see. So the T would be that completed equals the comp, right? I guess you need this. And so you would first check to see if there is a completed flag, right? If there's a query parameter, right, then just return that, then that, and then return. You do a return, right? And otherwise, you just respond with the to-dos. That's a more shorter, more compact way of doing the same thing, right? If there is a query parameter, then handle it, right? Compare it against whatever, right? Actually, this could live here, and then respond that, and then just return, right? Don't continue. Otherwise, then do the normal thing, responding with all the to-dos. Okay. So anyway, so in a dedicated component, right, we can create hyperlinks that go and fetch these objects, right? We can say, h2, fetch array, right? And so this could be a hyperlink that goes out to href, and then this would be http / localhost 4000 a5 to-dos, right? And so this would fetch array or fetch to-dos, right? And so then this could be a class of a button primary, and then we could maybe encode this, add it to our assignment 5, working with arrays, so that here, right, working arrays, so click on to-dos fetches the to-dos, right? So you're going to implement those hyperlinks of retrieving the completed ones, the non-completed ones, the by ID, right? But let's do something more interesting. How about being able to create new arrays, right? And so how we would implement that? So it would be something like app.get, right? It would be something like a5 to-dos. So how would you now let that pass in the fact that I want to create a new array, a new element in the array? Okay. So one way is that we provide the verb of the operation as part of the path, right, or the query parameter. But I do want to point out this particular approach, right, of using a verb as part of the path, right? And so there's request response. I'm going to create a new to-do. This is suggesting that I pass in the title and the completed in the query. Well, let's not do that. Let's just create a hard-coded new to-do. So we say const new to-do is going to compute a primary key. I'm going to use date. I prefer date. So I'm going to say new date, get time. I'm going to hard-code it with a new title of new to-do, not completed, and then I'm just going to push it into the array, right? And here I could do two things. I could return the new to-do, right, which is actually more sensible, but it's actually more convenient to return the entire to-dos, but it's not as realistic, right? Because these to-dos could be, the array of to-dos could be very long, right? Especially if you're a procrastinator. But no, in reality, these data structures could be very complex, right? And it could be very expensive to pass these data types back and forth. Nevertheless, right, so right now let's return the entire array of to-dos, only because it's going to be convenient a little later. Okay. So yeah, so let's see how that would work, right? I don't know if you can tell that this is not going to work, right? Oops. Right, so if I say to-dos, and I notice if I do a create, what do you think would happen? I'm going to fail, right? To-do not found. So what's happening here is that this is happening, right? This route is happening because I have a placeholder, okay, that the ID is what? Create. See that? This would never execute. This would never execute. Somehow I would need to here handle the create, right? Check to see if the ID is create and do that instead, right? So how can we fix this? Again, we could handle it in here, or I can move this. I can move this up. Okay. Now this is declared before this is declared. That means that the order in which is going to compare and try to pattern match, right? It'll first try to pattern match against this one, right? If it doesn't match this, then it'll go to the next one, right? So that means that .create /create is going to match this. It's going to add the new to-do, right? And then it's going to return all the to-dos. If it doesn't match create, right, and this is a 2, then it works, as we expect. But if it's create, then it's going to pattern match the first one. And so the order of the routes matter, right? So you have to be careful that sometimes, you have 2 routes that are colliding with one another, right? And one of them is winning, and the other one is never being called. Right? And that can be very frustrating for debugging. It says, here's the route, and I'm passing this path parameter, but why is it not working? And usually it's because you probably have another route that has exactly the same pattern. It's declared earlier, and that's the path that is being invoked, right? That's the route that is winning. So now if I do create, it does run. It creates the new to-do. There it is, and it appends it at the end. See that? Right, and if I keep doing it, it's gonna create another one and another one and another one. All right. Yeah, so that worked. How about we want to delete a to-do, right? So one way we could do it is that we can first identify the to-do that you want to delete, right? Maybe this one, or maybe number 2, right? We want to delete number 2. So there it is, I have it. And then maybe I can append the operation that I want to do on it, right? I want to maybe delete, right? Which now, nobody's handling that. But I could, handle it here. I could say, app.get, and it is, A5 to-dos, right? And you can give me the ID and then delete. And the implementation is that, I'm going to parse first the ID, and I'm just going to filter. I'm going to find it where it is in the array. If I find it, or if it's not found, I'm going to send you an error, a 404 error, and return right away. Otherwise, if I do find it, I'm going to splice it out of the array, and I'm just going to return with all the to-dos, the remainder to-dos, the one that I did not delete. Okay. And so now if I refresh, notice it worked. Actually, that's another point. Notice that it deleted it correctly, 1, 3, and 4. But what happened to the other ones that I had created? I had created 2 more. So what happened is that NodeMon restarted my server, right? Because I was updating a file and restarted the server, and means that I cleared out, right, those to-dos that I had created and went back to my original 4, right? Now that I have the 4, I filtered out and I spliced down number 2, and it's gone, right? And I can keep splicing and whatnot, right? Now I can create a few more. Say to-dos and create. Here's that one. I can create another one. Right, and say I want to remove that one. I can provide the ID. And there it is. That's the one I want to remove. And then I say delete, and it's gone. Right? So yeah. What about updating? Right? Maybe I want to change the title of a particular to-do. Right. So for instance, I might want to first identify a to-do, maybe 3. I want to identify number 3, right? And once I have identified, maybe I want to change the title. You can say, I can maybe retrieve the title. That will return the title of that object. And then maybe even one that I can give you a new title, right? New title, right? You would update the title. That would be cool, right? So let's try that. So that would be, app.get, A5 to-dos, right? :ID, and then we would say, title. And then, so if I ask you for the title, you would find that item and then return the title. Here, I'm doing something else, right? I am first identifying the ID of the element I want to modify, the new title that I want to change it. I'm first going to find the to-do in the array. If I don't find it, I'm going to send you back an error. Otherwise, if I do find it, I'm going to modify its title and then return the to-do. Actually, I'm going to return all the to-dos, right? And so that now, if I change this to new title, notice that it indeed modified it. See that? So I can change it to anything else and say, tag. You can change number 1. I can change the title to be, walk the dogs. Right, so I'm changing that one to be walk the dogs. Then, number 2, I'm going to, make dinner. Right, and number 3, wash dishes. Right, and then 4, put kids to bed. Right, and then I have all 4. See that? Those delete add operations are permanent, even if we restart the server. Nope, not if we restart the server. The only way for this to be permanent after restarting the server is if we save it to a file, right? If we restart the server, right, it resets it to this array. Okay, it is permanent as long as the server is running, right? If I ask for all the to-dos, right, notice that it remembers that these are the to-dos, right? But if I restart the server, I lose it. So the permanent solution is to save it to a file, right? Or even better, what we're going to be doing is that we're going to be using a database, right? We're going to be inserting all these data, updating, right, and deleting from a database, which will be our permanent storage solution, right? But that's going to be, starting maybe next week. Okay. Yeah. So then obviously the interesting part would be to create a web application, right? That had the input fields and whatnot, right? That would be operated here. So for instance, let's go fetch an array. Let's go fetch a particular item, right, in the array, and we can say, fetch item by ID, right? And so what ID we can provide here an input field where we can type the ID, right? So we can say, const ID set ID, right? And then you can have a form that allows us to type that ID, val ID change, okay? And then the hyperlink, I can go to this ID, right? And then fetch by ID like that, right? So that I can go back to the web application, 3000, And oh, use state. I need to declare use state. There we go. Let's go back to our labs 5 and let's fetch the to-do. So there it is, to do 1. Oops. Or to do 3, which serves fetch 3. Okay. Or that I want to modify, right? The title. You know, I want to update item title, right? So maybe we have a const title, right? Title set title use state, right? And then in here we can have an input field that allows us to edit the title, right? And then we have an hyperlink that passes the ID and the title and the new title, perfect, right? And then you can update the title like that, right? So that here you can type the new title of that particular. Oh, well, not to do. This is a. Oh yeah, it is a to do. Yes. And so this was, go to work, right? And so here's go to work, and you can set the ID. You can set the ID of which one you want to modify, right? And you have the go to work. So if I have here, I can see my to-dos, right? You have to-dos. There they are, and it'll modify, say, number 2, right? So I say 2, and then go to work. There it is. Yeah. If I refresh here, everybody notice that it has been modified. So I have a user interface that allows me to modify a data structure in the array, right? So yeah, so this is a somewhat of a rudimentary mechanism for integrating a user interface and a server. Really, what we want to do is be able to stay within the user interface, right? Not leave the user interface. Always stay here. In the background, we are going to talk to a server, make all those changes, and then catch those responses, bring them into the user interface, and then update the user interface according so that it's synchronized with the server, right? That's what we're going to be doing later this week. Okay. All right. Any questions? All right, so I'm going to push this to a repository, right? Both the web React application and the new Node server. And I'm going to share the GitHub repositories with you. Again, feel free to reuse any of that content as your own, right? And you should be able to get a leg up on getting going with the assignments. All right. All right, everybody. Good night.